Okay, so going back up to the top here. So still doing our matrix stuff. Now we're going to focus on just rotations. Okay, so rotations when we take and turn something, right? When they write these out, so before with reflections, it was a lowercase r. Rotations is a capital R. Okay, so if it has a capital R and then something kind of below it, that's a rotation of whatever degree amount it is. So it'll say like 90 degrees or 50 degrees or whatever, and that'll tell you how far you're rotating. The center of our rotation is always going to be the origin, 0, 0, so we're always turning around the middle of our graph. And then just a reminder, we talked about this a little bit before, and we talked about it in geometry. If it is a positive degree amount, that is counterclockwise, okay? And counterclockwise is, that would be going that way around. That's counterclockwise. Clockwise would be normal, just how like a clock goes. That would be in that direction, okay? So if it's clockwise, negative, counterclockwise, positive. And then they just give us some different matrices here to use if we have to rotate a certain degree amount. So if we have to rotate 90, 180, 270, or 360, those would be the matrices we use. And then the picture here just kind of goes with those rotations. So the original picture here is this one, the one without the primes. So that's our original triangular shape. And then each of these represents one of these things up here. So like this is our original shape. If we rotate it at 90 degrees, which of those do you think it's going to end up as? Do you think single prime, double prime, triple prime if we rotate 90? The single prime, right? Because if we're rotating and it's a positive 90, that would mean we're going counterclockwise, so we're going in this direction. And then what's nice about the graph is if it's a coordinate plane like that, wouldn't those all be 90-degree corners there? Yeah, so if we need to rotate 90 degrees and our shape is here, our shape is going to end up as this one here. So like I said, I'm going to color code them by just kind of like going over the lines there and then just making my rotation of 90 the same color. If you don't have the colors, you could also just write that one's like your A single prime one. Okay, so then our next one there, we're going back to our original shape. If I take my original shape and rotate it 180, where do you think that's going to end up? The double prime one, right? So if we rotate 180, so that would be this shape, rotate it all the way around here. That's halfway around because it's 90 and 90, right? So 90 and 90 makes 180. So again, I'm just color coding it. So that one there would match with rotation of 180. And then next one there, our triple prime probably is our rotation of 270, right? Because if we do a rotation of 90, 180, and then go another 90, wouldn't 180 plus 90 be 270? Yeah. So then I'd go 270 in a color. And again, if you don't have the colors, you can just write it as this was the double prime one, and then this is the triple prime one. And then identity matrix, we talked about this one before, right? So here, if we rotate something 360, what happens to it? It goes in the same spot, right? Because 360 would be like the full way around a circle, right? So if we rotate something 360, we're basically just ending up where we started, right? So that original one there, I know it doesn't have the extra primes and stuff on it because I didn't want to get too confusing there, but that one would be the same as our rotation of 360 because you basically just get back to where you start to, and then it would just be your original points, whatever they were. Now there are ways of like doing it by hand because you can go, okay, like, you know, this I went out 2 spaces and then up 1. Here I went up 2 spaces and then out 1 in that direction. There are ways to kind of do it by hand there as well, but I typically just use the calculator for these because it's just as easy in this case than trying to do it all out by hand. With some of them, like the reflection stuff, I do out by hand, but these ones, it's probably easier just to use the calculator on. Okay, so then we got one more theorem to write here, and then after that we just have one example to do. So jot that theorem down there. that's giving blood tomorrow, make sure you're drinking lots and lots of liquids today. Okay, so let's take a look at this composite of rotations theorem. So composite again is where we do like one of them and then we do another one of them. You could do more than that too, but usually it's just two for us. So it says a rotation of b degrees following a rotation of a degrees with the same center, so 0, 0 or whatever, results in a rotation of whatever your a and your b degrees were added together. And then in symbols it shows that like rotation of b following rotation of a is a rotation of a plus b, okay? Logically that kind of makes sense because if you're doing this and like this situation here they give it as an example, you're rotating 90 degrees, following that is another rotation of 90 degrees, right? And then that would give you 180. So like if we think about that up here, if we took our original shape, rotated it 90, and then rotated it another 90, don't we just end up in that same 180 spot? Yeah, so if you take something, rotate it so far, and then take that shape and just keep rotating it around, instead of doing that twice, what you can do is you can just add those two rotations together to get the total rotation amount, okay? And that's kind of what they kind of show here. You would just multiply these two matrices together, and then that would kick out the same matrice for rotation of 180. Okay, so then we just have one example to do for this stuff here. And it's a pretty basic one, so it just wants us to find the matrix for a rotation of 450 degrees. So 450 degrees is not one of them that we had listed out, right? But what we can do is we can think, okay, well, if I rotate so far and then do another rotation on top of that, could I get to 450? Okay, so what we have to think here is, to get to 450, which numbers that we already know could we combine together to get 450? And so if we try it, so what we could do is we could do, so our number we're trying to get to is 450, right? So if I did 450 minus 360, I get 90, right? So if I did a rotation of 360 and then a rotation of 90, wouldn't I get to that same spot? Yeah, so if I do this out here, so going back here, it would be a rotation of 360 and a rotation of 90 should total to be a rotation of 450, because 360 plus 90 equals 450. That's how we're getting those two numbers. Then what I would do to figure out what that matrix is, I would just take my matrix for the 361, so 1, 0, 0, 1, composite, oops, not composite, ignore that, multiplied by 0, 1, negative 1, 0 is the one for 90. And then I would just take that stuff and I would just type it into my calculator. So I would go to my matrix stuff, so second matrix, over to edit. They're both 2 by 2s. So first one would be 1, 0, 0, 1. Oops, no row. Okay, there we go. And then I would go second quit to get out of it, second matrix, edit the second one to be a 2 by 2. And that one would be 0, 1, negative 1, 0. And then I go second quit again, and then I would just multiply those two. So second matrix, it'd be your A1 times your B1. Hit enter, and then it'll kick out the matrix we need there. So the matrix it kicks out is 0, 1, negative 1, 0. And really here, if we kind of think about this logically, what happens when we rotate 360 degrees? It goes back to the same spot, right? So if we had, our shape or whatever it is, we rotate 360, we're back to that same spot. So if we're rotating 450, wouldn't that just be the same as just a single rotation of 90? It would be, right? So that's why those kick out the same exact answer, because this is the identity, and this won't always happen, but this happens because this is the identity matrix, and then that was our 91, so it's the same as a rotation of 90 degrees, because if we take it and rotate it 360, just back to where we started, so then we just have to do the additional stuff past that. Now, that's not always going to be true on all of these that we do out, but just for the purpose of this one, that's kind of why that happens. Okay? Okay. So, just making sure you're getting that book page done for tomorrow.